I just want to welcome everyone. My name is Rich Gay from Missing Movies, and my guest today is Linda Tadic, who is the founder and CEO of a company called Digital Bedrock. And Linda is one of the leading experts on digital preservation. She is also an adjunct professor at UCLA. Um, there are several great talks that Linda's given on this topic. Very detailed, specific things that everyone should know. Uh, you'll find links to them at our resource page at missingmovies.org. But right now, Linda, welcome. Thank you for doing this.
Thank you, Rich. This is such an important topic. I'm happy to participate in any way.
That's great. And I want to come at this because I know you do these talks for archivists and preservationists and things, but I want to come at this from the standpoint of a filmmaker. We no one ever tells us anything about preservation, and we always think preservation, that's for all those silent movies from 100 years ago. That's kind of what most filmmakers think preservation is. So I want to talk about today, and let's take it from the point of view of I am a filmmaker getting ready to make a film. What is it that I should think about when it comes to preservation?
Okay. Well, the first thing to think about is, okay, you're going to be producing various digital files. This is assuming somebody is producing a film in digital format, because that's the current method these days. What would be required from those files that are created in case in 20, 30 years of that film you would want to restore it? Perhaps then, who knows the technology? Right now people are looking at, okay, there's 4K, there's 6K, there's 8K. Will there be immersive environments, where they want to put their film into maybe a game or into some kind of environment where people can just participate and be one of the characters in the film? You never know in the future what can happen to the content that you're creating today. So if you needed to, number one, restore it, pull it all together again to recreate it as it was at the time of production, or also then to repurpose it into some other use in the future as yet to be determined, what do you need? What elements do you need? And so, in working with producers and studios and seeing what they are preserving, I mean, that's a rule of thumb. And so it would be wonderful if producers, if maybe your project could come together, make recommendations. These are the elements that at a minimum you should preserve per film that you make. Everything from picture sequences, and everything should be in all the audio masters, everything. Is it a heavy visual effects film? Do you want to save those visual effects, but are they in file formats that you would then be able to repurpose in the future? Because who knows, in the future, there's no software available or, to create, to play those files.
Right.
Which is why you want to create in as open formats as you can, which is pretty much what, for the masters that I've seen that people do, that they are pretty open formats. So again, what are the picture, what are the sound elements that are required in order to render or restore or repurpose that content in the future?
Okay.
Yeah, so that's number one.
Okay. And so let's just stop there for a second. So I've got all of my original picture files, all of my original sound files on a drive, because that's where we keep them. What should I do with those original files? I mean, I'm in a situation right now where I have the mother drive from a number of small films that I produced. And the question is always, it's sitting there taking up storage space. What do I really do with this stuff? What do I need this for? So I guess the question is, how would I approach that? What would I want to do with those raw files?
Okay, so you have the content. So now we're going to shift into how you preserve those files, which is bringing up. So the first thing you want to do is, when those files are created and you feel like this is locked down, this is the file that I want to save going on into perpetuity, you create checksums for those files, for every single file. And don't forget the audio. Quite often people will make checksums for the picture masters, but they do not for the audio files.
Can I ask you to just explain what a checksum is briefly?
Mhm. Sure. So a checksum is basically, it's a unique fingerprint. So just as every human on the planet, we have our own unique fingerprints. Every single file that is created has its own unique fingerprint that cannot be replicated with any other file unless something's been hacked into it. And so the checksum is basically, it's an algo, it's a hash. So it's going to be like an alphanumeric string, just letters and numbers together, which if any bit changes, and that bit can change because that file has been touched or modified in some way, even if a little slight change happened to it, that alphanumeric sequence is going to be modified. It won't match the original fingerprint. Or if you deliver that file to somebody else, the rule of thumb would be like, well, now you're going to verify that checksum when somebody receives it to make sure that no bits were lost during transfer. So basically you create that from the point of creation, just as when we're born, we are born with our fingerprints. You create that fingerprint for your files when you feel like they are finished.
And what is that process like, that creating that checksum?
Well, there's a lot of open source tools that can be used. I mean, you don't have to pay money for a product to create them. There's even, if you're on a Mac, you can create it. And I'm not a Mac user, but I know that people use an application that comes out of the box on a Mac computer to create checksums. So you want to have a list. So basically to verify it, so you want to have a list of the directory structure and the file name. So those could be like two different columns. Let's just talk about Excel. None of this is really has to be complicated, right? You need a fancy system to manage your files. So you have an Excel list that has a path, a file name, and that checksum. And you want to know what was the algorithm that was used to create it, because there are a variety of algorithms. And if you talk to post houses, they usually make what's called an MD5. That's a low-level checksum. And that's just basically, or an algorithm, that's what is used just to verify that the file's okay. And then there's several flavors. And then what we use actually is SHA-512. So when we receive content from organizations or producers or whatever, we verify their MD5 to know that the files we received are good, nothing happened. But then we create a SHA-512. So let's just say, like, if an MD5 is this long of a string, a SHA-512 is going to be this long, which takes longer to create, but it's harder to hack into in the future. So we're thinking already of the future for when quantum computing comes out, and it'll be a lot easier to spoof those checksums, those MD5s. It's going to be a lot harder to spoof the SHA-512 because it's so complex.
Got it.
So that might be more detailed than you want about checksums.
No, I that's great. And so I guess so I guess the options here, I mean, there's a lot of raw data, a lot of files that go into a feature film, especially, these are very big files for picture. So I guess there's the going and doing this all for the raw materials, but then there's also the finished product, right? I mean, we go through the entire editing process, the color correction. We come out with a finished file. Maybe it's a ProRes file. There's a DCP that's created, let's say. What are all the, because a lot of times, and I've done this myself, thinking, well, I've got the file, I've got it on a hard drive, so I've preserved it, and then of course the file doesn't boot up. The drive fails. I have a drive sitting here that I'm trying to get a power cord for, because I don't want to put the wrong power cord into it, and the manufacturer no longer makes that drive. And so I'm trying to, figure out how am I going to access the data on that drive. So so I guess what I'm alluding to is I feel like drives give a false sense of security. And what's the other sort of physical media that I might create in addition to just having things on a drive?
Well, one thing, it's just a fact of life that media will fail or it becomes obsolete, no matter what it is. It can be a hard drive, it can be a solid state drive, it can be data tape. again, there's obsolescence factors, the generations get old, or hard drives, if, especially the really small, flimsy ones,
Mm-hmm.
you get the click of death. That's because like the attenuator arm has broken off. It's very flimsy,
Right.
and then you have to go through this expensive process of getting the drive out of it, the magnetic device, putting it into another one. So it's possible to restore it,
Right.
in a disaster. So you have to store it somewhere, and then you ultimately also, like the fact of life with digital files and preservation, is you're going to migrate it off of that media over time. And again, it doesn't matter if it's on a drive or in a server or on tape or whatever, it will be migrated off, which requires management for people to do that if they're doing
Right.
it themselves.
Right.
So it depends. So when you're thinking about, again, so the first question or the first thing I mentioned that has to be decided is like, what content do you want to preserve?
Right.
And so it's not just the ProRes or the DCP, because those are more like access copies, but what are the masters, the picture sequences, the graded and the ungraded? So the ungraded would be, that's the raw one. That's the, let's say,
Mm.
DPX sequence is ungraded. So you would go back to that and preferably in the resolution of whatever the camera shot it in. So let's say that even if you're releasing the film in 4K, it was shot in 6K, or if
Right.
you're doing in UHD or whatever, you want to save the ungraded at that 6K if possible, which means big files. You
Mm-hmm.
only go back to those if you ever need to recolor, redo something, with those files or do something to it. That's your master. Then you have the graded ones, and you want to keep the LETs, and any of the project files and all of that. So that's two set of picture sequences that you might be saving. So that's a lot of storage.
Right.
Then, of course, all of your audio masters and your print masters, your stems, M&Es, Atmos files, if you keep.
Mm-hmm.
So that's a lot of data. But you would probably hardly ever, once the picture is put to bed and it's been released and you have your access files, you have your ProRes, you have your DCPs that are
Mm-hmm.
going where they are. Again, those are for access. What do you do with those masters that you won't ever touch again
Right.
until you need them in the future? But that's what you want to preserve. That's the core material to preserve.
Got it.
So putting it on spinning disk on which is hard drives, those will fail. And as you said, then you have the cables, especially because things change.
Right. Yeah.
So, so the most stable and the least expensive medium that I think one could use is LTO data tape. And so even though that will change generations over time, so you have to migrate it, there's going to be a wide span of years, longer than if you had those files on a hard drive.
Mm-hmm.
Lasts longer on that data tape than it will on the hard drive.
Is there I understand there are going to be generations and and things, but is there an amount of time that those things will that I can expect the LTO to be good for? I mean,
Mhm.
is it 2 years, 5 years, 10 years?
Well, it isn't the data tape itself, it's more like, do you have the drives that can read that generation?
Got it. Right.
And so that's the main thing, because if you make that LTO tape and you store it on a shelf in a good environment, and it can just be an office environment as long as it's not too hot and humid, as long as it's not too cold and dry,
Mm-hmm.
just like a regular environment, and nobody touches it and it's just left alone. But
Right.
the critical thing is to verify that you wrote the file to the tape, and then you verify the checksums to make sure that nothing got corrupted along the way. And if you verify that checksum on the tape and you make more than one copy, of course,
Mm-hmm.
you want to have geographic dispersal for disaster
Right.
recovery.
Right.
So the rule of thumb with archivists is you have 3 copies, at least 3 copies. So that means if an independent producer filmmaker is doing this themselves, they could make 2, they could make 3 copies and then store those copies somewhere else, keep
Right.
one themselves and store the other somewhere else. So
Right.
anyway, but as long as you verify that those copies were written correctly
Right.
and they're just sitting there, they'll be good until you need them. There
Okay.
should be nothing wrong with a tape. I mean, the manufacturers say that it will last 30 years, which
Hmm.
you're going to migrate it before 30 years come to pass. You're going to migrate it to a new generation.
Right. Or hopefully we'll get into that in a minute, but it's hopefully someone will if I'm
Yes,
not around.
right.
But
Yeah.
yes, so it's interesting because it feels very much, just to put it in, sort of in my perspective, doing research on a documentary and went to a huge universities or where this organization I was working for had their archives. And oh, there's some really interesting VHS tapes. And I went to the librarian at this university and I said, these, can I take a look at these? And she looked at me as if she had no, like they didn't have a VHS player there.
Mm.
And so there was a scramble, and about an hour later, we found a professor, an old professor who had a VHS player in his office that we borrowed. So I think that that's another aspect here that, people have to really understand is it's the players. I mean, I have never thrown out a device that works. I have all sorts of formats in my storage unit because I never know when I'm going to need that VHS or the VHS-C or some crazy format.
Mm.
But
Mhm.
I think that's a good reminder that it's not so much will the tapes last, but will there be anything to play them on?
Yes, exactly. Right. Because I mean, LTO tape is very robust. It's a really good stable format, and it's small, and the media itself, so it's less, it's tiny little, like half of a VHS size, basically talking about VHS.
Right, right.
Right, so it doesn't take up much space. It's very stable. And the media itself, so let's say that you're at LTO 8 today, and that's $60 for 10 terabytes.
Uh-huh.
Yeah, and so the media stock itself is very inexpensive. So again, if somebody wants to write their data tape themselves, the LTO
Mhm.
tape themselves, they have to buy a drive for
Mhm.
whatever generation they want to write to. Obviously, you need a computer that's connected to it, and
Right.
again, the rule of thumb is you use open software, open standards for writing, so nothing is locked in any proprietary backup system. And so what that means is for LTO, you're going to write using LTFS, which is the Open Linear Tape File System that the LTO Consortium developed.
Okay.
Basically, then if you have this LTO drive, you have the LTO tape, you put the tape in the drive, it's plugged into a computer. It looks just like you have a hard drive plugged in. You
Huh.
see exactly
Okay.
that folder structure, exactly as a hard drive.
And then it's as simple as transferring from your drive to to that drive, basically, right? Writing. Okay.
Mhm.
And what, just out of curiosity, and of course, we're not holding you to any numbers, but what is a drive, an LTO-8 drive? What's the price range of that today?
An LTO drive is usually right now is between $5,000 and $6,000. That's for a
Okay,
desktop drive that you could just put on your table right there in your home office,
got it.
and do the writing. Now, as every generation is released, of course, the previous generations get less expensive.
Right.
So LTO 9 is the current generation right now. But
Okay.
those drives would be more, it depends again if you want, so drives can be in either half height or full height.
Mm-hmm.
Full height are more expensive, they're more robust, they can write a little bit faster. So the full height drive for an LTO 9 could be like $8,000,
Mm-hmm.
but the half height is still around the same price point, like $6,000 as an LTO 8. So
And I assume so. Okay, and I assume there are companies that will do this for you, right? If
to
you don't want to buy it, if I don't want to go out and spend the money on a drive and do it myself for fear of doing something wrong, uh, there are companies I assume that will do this
Oh, sure.
as a
Yes.
service. Yeah.
Mhm.
Okay.
Yes.
Okay. It's interesting because part of the whole thing with LTOs, and I know that they've been around a long time, but again, as a producer, that's part of the thing. It says it on on a form to do. They're going to do an LTO tape backup, and you never really understand what that is or what it's for. You just say, "Oh, okay, that's what they do." So it's interesting to understand that is a really durable format. So would you say at the very least, if you've completed a film, that you should at the very least make an LTO of the finished film? I mean, as opposed to maybe I don't have the resources to do the entire, or, all of my raw footage. I understand the drawbacks, but at the very least, to preserve that film, I should create an LTO of that finished product.
Right, but again, that goes back to like the finished, edit, the picture sequences. So
Yeah,
you might not want to save the dailies,
right,
or any of the other ancillary files, but definitely save the final, edit, the
right,
picture sequences, the ungraded, the graded, if
right,
possible. The LUTs, again, anything that you would need if you needed to restore this again for any other
right.
future purpose.
Great.
Right.
Okay.
And as far as the tape sizes, it seems like it depends, of course, at what resolution the film was shot at,
Mhm.
and what it was captured in. Given the size that can fit on one LTO8 and one LTO9, you could fit all of those elements I described on one LTO9 tape, which is roughly 16 terabytes usable. It's advertised as 18 terabytes, but there's a partition and it's really, really is only 16 terabytes usable. And LTO8 tape, you could do it on 2 tapes.
Right.
And so LTO8 tape is again advertised as 12 terabytes, but it's really like 10.2 terabytes usable space on it.
Got it. Okay. Now let's talk about the hard, well, at least what I think is the hard part. The idea of who is going to take care of this, who is going to do that, the migration as we move decades into the future.
Right.
Is that the place where you try and store these at a legitimate archive like UCLA Film Archive or something equivalent?
Well, one would have to do their research to find out what the archive would actually do with that tape.
Okay.
So let's say you give an archive an LTO tape. Do they have the infrastructure and the capability to do that migration? What would they do with the files on it? So again, it's not the media that's important, it's the content that has to be stored on the media. So are they actually going to then restore the files off that LTO and put it within their own system, like a server system or whatever they're doing internally?
Mhm.
Or is that LTO just going to sit on the shelf in the archive? And if
Right.
that's the case, what are they going to do with it? I mean, the thing is like, even if people are thinking about migration, so let's say that let's say, for example, somebody has LTO4 tape, which is definitely obsolete, definitely out of there, and they don't have the infrastructure to restore off LTO4. You can go to service providers and ask them to restore the files off. I mean, it's what we do, but there are other people other than us who can do that
Mhm.
as well. And so that's just a service. So that doesn't necessarily mean it's a disaster if your data is on LTO4. But again, going back to the archives, find out from the archives what generation will they support of
Right.
LTO, and then what are they going to do with it?
So that's interesting. So again, because we're all familiar with hard drives, so if I buy myself a new hard drive, and I take my old hard drive, I just simply copy the files over and I'm done. But am I understanding that with the LTO tape, that has to be restored? Is it the same process as having having a new hard drive, and or is it that the LTO, the elements have to be restored and then from there transferred to the
Oh,
to
I'm
the
sorry. It's all semantics. So in in
yeah.
in in data world, when you talk about restoring an LTO tape, all that means is you're getting the files off it and you're putting it
Oh,
somewhere
okay.
else.
Okay.
Yeah,
So I'm not okay. So I'm
yeah.
not
It's
going
not
back
like
into any other system. I'm basically I am plugging in an LTO8 drive and an LTO9 drive and copying over. Is that's it?
well, just to segue a little bit. So LTO9 drives can actually read LTO8 tape. So
Okay.
that's one of the nice things about LTO9. You can do either 8 or 9. That's fine. But
Got
let's
it.
say you want to migrate some of your old LTO6 tapes. You have files on LTO6. So you need to restore those files to something. And so sometimes often the process will be you restore, which means you're reading that tape, you're copying the files off of it. The files are still on the tape. You're just copying
Mhm.
the files off onto a server or some other intermediary storage device. You check that those files are okay, because it's not, you don't just want to go from tape to tape. You want to verify those checksums if you have them. Are the files
Mm.
still okay?
Okay.
You write them, and then you're going to consolidate files. So So, oh gosh, boy, let's say like 10 LTO6 tapes can fit on one LTO9, the
Oh,
data,
wow.
right?
Okay,
So as the generations, become more current, the storage on them gets bigger also.
got it.
So what you have on multiple tapes can fit on one tape. So then you're also saving space that way too by consolidating. So anyway, you want to restore those, copy the files off, the
Mhm.
old LTO, make sure the files are okay with checksums, maybe reorganize them a little bit while you have them on a server,
Right,
so that they're in a clearer folder structure or whatever. Then write them off to the new generation. Let's just pretend it's LTO9. You want to verify the checksums when they're on LTO9, make sure it was all written okay. So that's that whole migration process at a minimum. That's what, and then of course you want to be able to track what was on those original tapes, what files, and which files are now on this one LTO9 tape. So you need
right.
to manage that as well.
Okay,
And check for any format obsolescence. So digital preservation is more than just, okay, these are the files and we're going to put them onto storage.
right.
Especially if these are older digital files, is there a chance that the files themselves could be no longer supported? There's no longer software out there that can render the files, that can play.
Mm,
So in order to even know that, then you need to know all this technical metadata about the files. How were they created? What are their technical characteristics? Just to think then, okay,
and
yes.
is that information available to you from just the file, or is there some other record of that's needed?
Files are wonderful because they will tell you if they have that information embedded in the file, they will tell you what it is. And so you can use,
Right.
again, open source tools, anything from like media info is a common one. You can, it's an open source app. And so you can also just put that on your computer,
Hmm.
a file into media info, and then it will export out all the information that it pulled out of the file. So it will tell you the resolution, it'll tell you the date it was created. Yeah, it can even, if it was embedded in the file, what software, what was the operating system environment in
Okay.
creating the file.
And do you ever run across a situation where that software is no longer available, or so? Because it seems to me software is constantly updated, and there'll
Yeah.
be versions of software that are no longer supported. And so, how do you deal with that?
Right, exactly. Well, then the creator who created the content or whoever's the steward of it has to decide, all right, what are we going to do?
Hmm.
And so you have a couple of options. You can leave it as it is, and you can
Right.
go and try to find the software and the operating system that's required to run the software, which
Hmm.
usually means that itself is also obsolete.
Right.
And so how do you get that? And so, or you can try to transcode the file, into a more current format, unless it's project files. You can't really, that's harder to do. But if it's
Right.
a content file, you try to transcode it, but then you might lose color information or other. So that's why like the creators
Hmm.
need to do that themselves to verify that if I'm going to change this file to a new format, does it look correct? Was anything
Right.
lost in the translation?
Right. Right. Interesting. Okay. Yeah, it's there are a lot more moving parts than having a piece of 35 millimeter film that you can always shine a light through and
Right.
see what's on it.
Yes.
Yeah, yeah. Interesting. Okay.
Yeah.
Uh and where do you see all this, where do you see the preservation heading? I mean, yes, the LTO, the physical media seems to be the most durable. Um, but 50 years from now, what do you think that will how will this evolve?
Well, first of all, it has to evolve because all of the rare earth materials that we are using to create this storage media, the hard drives, the solid state drives, less so LTO, but definitely the spinning disk and the solid state drives, which is in all the data centers around the world and
Mm,
in our homes, there isn't enough material on the planet, to keep creating these for 50 years. And all of the manufacturers know this too, which is
mm,
why they're trying to do more for reclamation, recycling of magnetic material, for example, or aluminum, all of the rare earth materials off of the drives. But it's taking a while to get to that point, but they actually are trying to because they can see the writing on the wall.
mm.
This is going to go away. So there has to be another storage medium in 50 years. There just has to be. There's no choice about it. And so there's been a lot of R&D work on a variety of different kinds of storage media. One is DNA storage, synthetic DNA, not human DNA,
Oh, wow.
synthetic, yeah. Glass, etching information on glass. Those are the
Uh-huh.
two that are, for the most part, have received the most R&D money. I mean, you follow the money, and that's what's going to make this all develop, correctly.
Interesting.
So I am betting on DNA being the storage medium that will be used. There's a lot of, in fact, I'm involved with the DNA Data Storage Alliance, trying to develop an interoperable standard for DNA encoding and decoding.
Hmm.
So
Okay.
basically, you still create your digital files, but they're all stored not on spinning disk, not on data tape, not on solid state, but in these little tubes, that have these strands, and it can store petabytes and petabytes and petabytes of data.
Wow.
Yeah, so some of the problems with that, of course, is like, how do you do random access? What if you just need that one audio file?
Yeah.
It's really
Right.
nice. And
Right.
you really need to decode petabytes of data just to get to that one file. So that's what some of the things that they're thinking about, about
Interesting.
how to solve that problem.
Wow. Okay. Okay. And again, because one of the things that we're advocating filmmakers do with their contracts is, well, first to know who owns the copyright to your film, uh, and second to know what physical materials exist and where are they, who has the original elements, and what do they consist of, whether it's a DCP, whatever LTOs, whatever materials. So I guess and then we're also advocating that an LTO of the final film should be created, multiple copies, and stored at archives. But I guess part of this now is what I've learned just now from you is, well, you need to know what that archive intends to do or what they have the capacity to do with that. I mean, right, in terms of migrating it and moving it forward. Because if it has an LTO4 tape 50 years from now, you may not have preserved your film with that.
Exactly. Right. If all it's doing is sitting there on a shelf and it's not helping anybody. No.
Right, right.
Yeah.
So it's really about talking to the archive and really getting an understanding of what it is they are promising to do, right? I mean, that's
Right.
yeah.
And to keep that data alive, because again, yes, it can just sit there on a shelf,
Hmm.
embedded in that LTO tape, but as far as like any of the other, are they going to do checksums to make sure the files are still okay? Because
Mm.
normally what you want to do is do what's called in digital preservation language a fixity check, which means over time, according to a schedule, you're going to take that tape off the shelf, put it in a drive, make sure the bits are still okay. And again, we've written like 33 million files to date, and every single one is fine, but that's because we have such strict protocols to verify the checksums along the way. So will the archive also do that, and make
Right.
sure the files are still okay?
And how much of that is an actual manual, like a human process, and how much of that is automated, or what's the potential for automating that? Because it sounds like a lot of work for.
Well, I mean, there are automated tools. I mean, we have our own tools, and so it's just automated. We just have a schedule and say, okay, it's been a year since this, tape, the
Mhm.
files in this tape were checked, and then we just put it in the robots and we push a button and it knows to verify against the
Got it.
checksums that we have in the database and verifies that they're okay.
Got it. Got it. Okay. Um, okay. Well, any parting words of advice for filmmakers who are concerned about their work being available
All
in
right.
in in the future? Anything?
I think it's an excellent idea that they should put, whether you're an independent, just starting out, or whether you're actually creating something for it to be streamed or licensed by a studio or whatever, put into that production budget, preservation of the file, put it in
Mhm.
the production budget, whatever. Because oftentimes what I've seen, and as you well know, is like, okay, a film is finished, maybe at a post house, and then it's gone. Where'd it go?
yeah,
You know, the post house isn't responsible for keeping it,
yeah,
you know, and so it's gone.
yeah,
So the responsibility for that should be put into whatever contract, or if the filmmaker's just making this on their own, of course, they should be thinking about that and then thinking about, well, what does that preservation mean? Because you have to put a line item in the budget. Well, what's the cost then?
exactly,
So how do you
exactly.
determine that? And
Yeah,
is it going to be ongoing? So it's not just a matter of putting in the budget to write an extra copy of LTO, but it's about like, all right, so if it's going to be managed over time,
hmm,
what's the budget for that? Because you can't just store and ignore data. It's not like
right,
film you can store and ignore it. This, you have to manage it over time and make sure it's okay.
right, right. And is it fair or unfair to hope that if you are in the right archive, that they will agree to manage it? I mean, is that a fair thing to expect of an archive?
I know, honestly, I know very few archives that have the capacity to do that. And it's not
Hmm.
against the archives, it's just that it takes infrastructure, it takes money, you know,
Right,
it's,
right,
yeah,
right,
yeah.
right, right. Well, that's
Yeah.
interesting. Well, as I say, what we're trying to do is just bring these things to light, just give people awareness of this. We're going to try and, as best we can, help filmmakers whose films are lost right now,
Yeah.
but also trying to alert filmmakers who are about to make films to in ways to help preserve it. We can't solve all the problems. we you
Mhm.
know but I think the creating that LTO, knowing that it's there, and that at least that is, even if it's on a shelf somewhere, knowing that you at least have that,
Yeah.
and is a first step. If you don't have that, you know you're truly lost. So off the top of your, and again, I'm not no one should hold you to any dollar amounts we're talking about, but to create an LTO of a feature length film, I mean, I know it depends on the file and all, but what might it cost to do that?
If somebody's doing it themselves,
Yeah,
okay, so basically you have to buy a drive,
right,
and let's just say LTO8,
mhm,
or LTO9, which is the current one. So
right,
you buy the drive, which can be anywhere between, if it's LTO8, $5,000 and $6,000, but you'll be using that for years and years and years. So that's a
right,
one-time expense. And
right,
then you just have the storage media. So again, let's just stick with LTO8 for now.
hmm,
So the media, one tape is $60
mm,
or less. So
okay,
and you can fit a feature film, let's just say on two tapes. So then if you make multiple copies, let's say you make three copies, so that's six tapes
uh-huh,
altogether. Two times three is six tapes. So that's six times $60. So it's like, what, $360? Is
right,
that right?
okay,
Yeah. So for the media, and that's it. Of course, you then need to just at least at a minimum know what's on those tapes, and you can create the checksums by using open source tools. You can make a list of file inventory of what's on the tapes, even just in Excel, or a
uh-huh,
CS list. So
uh-huh,
again, it doesn't have to be fancy,
right,
as long as you're,
right,
and write it in LTFS, which every single LTO drive out there comes ready to write LTFS.
okay. And I guess you just, whatever your best version of that film is. So if it's a ProRes file, or whatever your final version of that film, the best resolution, etc., is what you would use, right? I mean, I guess
Well, when I was talking about the like two tapes, that's including you're going to have your picture masters, your ungraded and your graded, and I'm talking about
right,
DPX or TIFF or EXR
right,
file.
right,
Yeah,
right.
because that's what you'll go back to.
Got
Yeah.
it. Okay. All right. Well, that's great. I really, I appreciate it. And appreciate you taking the time to lay this out for us. I hope it's been helpful for everybody. Again, this is Linda Tadic from Digital Bedrock. You can look the company up. I highly recommend them there. It's a great tool. And as I said, a lot of other videos that Linda has been a part of and presentations we're gonna link to them on our website at Missing Movies. So thank you very much for doing this.
You're very welcome. And everybody preserve your work.
Yes,
Yes.
preserve your work. I agree.